as a first step, given that we have a product of two functions, we will use integration by parts with u equals to sine x and dv equals to e to the x dx. Then du by dx equals to cos x, and therefore du equals to cos x dx, and integrating v equals to e to the x. Therefore, plugging these into the integration by parts formula, we get I equals to e to the x sine x minus integral of e to the x cos x dx. Now, notice that we have another product of two functions inside this integral, so we can use integration by parts again with u equals to cos x and dv equals to e to the x dx. And therefore, du equals to minus sine x dx and v equals to e to the x. Now, plugging these, the integral becomes e to the x cos of x plus integral e to the x sine of x dx. Here, just a quick one to say that I publish new videos every week, so if you want to boost your calculus skills for free, then be sure to hit the subscribe button below. Now, plugging all of this in, I becomes e to the x sine of x minus, open brackets, e to the x cos of x plus integral of e to the x sine of x dx. Now, notice that this integral term is in fact the question that we started off with, and therefore we can replace this with I. So, the equation now becomes I equals to e to the x sine of x minus e to the x cos of x minus I, and then we can simply rearrange to make I the subject to get I equals to e to the x, open brackets, sine of x minus cos of x, whole divided by 2 plus c, which is your answer. If you enjoyed the video, then please hit the like button below. Thank you.